Hi everyone, welcome to our webinar today. I'd like to just give you a little note to remember to fill in the survey at the end of the webinar. Our marketing team really appreciates it if you take just a couple of minutes to give a little bit of feedback. Throughout the webinar, we're going to cover quite a bit of material, but as we go along, you could enter questions that I will go on to answer at the end. It should be relatively straightforward to see where you enter the questions with the GoToWebinar software. So thanks everyone for coming. I can see there's more people arriving as I speak. My name is Declan Trezise. So good morning, good afternoon, good evening to everyone who's turned up today. I'm based in the UK. It's already dark here, although not so much in my office. I'm the Director of Applied Engineering at Basis Technology. And today I'm going to talk to you about one of our products, the Rosette Name Indexer, in this webinar, which is the third in a series of AI innovation stories. It's actually a follow-up to the webinar that we did in December. And the December webinar talked about how the nuances of name variation require a modern AI-driven name screening tool in order to be able to match them. So today we're going to follow that up with a demo, and we're going to see how vanilla search compares with the Rosette Name Index for name screening. And I'm going to jump straight in because I want this to be short and sweet and not drag on too long. Hopefully everyone can see the screen that I'm sharing now, and the screen shows just a few of the places where name screening or identity screening might be relevant for customers of ours. In the top left, you'll see something that alludes to medical records. The picture is of just a baby's foot and an identity that goes along with it. Within medical records, it's important to keep track of your patients and understand the history that they have had in terms of treatment they have received. Underneath that, I've got another positive use case for looking for people's names. It's actually a hotel lobby. When I did my test run through of these slides, the person I showed it to said, what is that office in the bottom left? So it's a hotel lobby, and often you'll find that hotels or chains of hospitality businesses will need to keep track of who is on their preferred customer list or who is checking in that day, and they need to get the identity right, often just using the name and maybe a few other bits and pieces. On the right hand side, I've got two use cases that are looking for bad people or bad actors and agents. The top right is a ship. It's a container ship, and it's transporting freight. That freight could come from any number of companies going to any number of companies, and the contacts up there are subject to screening. And also the crew of the ship, whether they're crossing international borders, will also need to have their names and identities checked against international watch lists as well. And then the bottom right, it's money. And we all know that when it comes to money, you are often subject to a huge amount of regulatory checks, and your bank will run screening when they want to onboard you as a customer, whether they're doing ongoing screening for anti-money laundering purposes or KYC, know your customer. Your name and identity will get checked against watch lists to see if you're a financial criminal or if you're a politically exposed person. So these are all important places where name screening is required. But what makes a good name screening tool? This is a little bit of a recap maybe of what you could have seen on the previous webinar, so I'm not going to spend too long on this. What does good name matching actually have to deliver to be fit for purpose? We've got customizability up front there, top left, the first thing that you look at. So what is a customizable system? Why would you need one? We're going to cover a little bit of that in the demo, but it's important also that if you can customize a system, that you can actually keep track of the impact of those changes as well. So you don't want to be customizing a system thinking that you're fitting for one case and actually breaking the matching algorithm for other cases. And then we have things like accuracy and speed, which are almost a given. You're not going to look for software that isn't accurate or fast. But explainability is something that's relatively new here. Explainability is something that regulators are asking for, and there should often be an audit trail when it comes to data processing specifically around things like identities and names. Okay, if you've seen any other basis demo talking about name matching, you might be familiar with some of these ideas. If you haven't, maybe you haven't thought about how difficult it might be to match a person's name, or even a company's name or an address. So these are some of the phenomena that might be involved. Some of the ways that a name might be changed or manipulated or obfuscated involving things like this. Everybody's familiar with the idea of a nickname. And if you go by your nickname, perhaps it doesn't match your own name as written on your identity documents. Maybe people write their names with parts missing. So I have 3 middle names, and generally I won't write them down except for when I'm writing to my bank or applying for some financial product, something like that. There's 2 in here though that are subtly difficult in a different way. So on the right hand side, it points to the idea of names in different languages. So maybe if I told my name to somebody who came from a different place, they would write it in the way that felt natural to them, but that wouldn't be the way that I would write it. Or they may even write it in a completely different script or alphabet from the one that I use to write my own name. And then it becomes a challenge to match the way that that name might sound in one language to the original version of the name that was spelled natively. And then on the left, there's a tiny little thing in this word cloud. Maybe we should have brought that one out, but it says semantically similar names. So here, 2 names may share a meaning, but they don't necessarily share words or parts of the words that are required. So something might be the same name without actually having the same words in, which is an interesting variation. So here I'm going to put up this slide. And yes, it's not a very exciting slide, but my marketing team actually came up with a fun analogy for the differences between what a vanilla kind of name matching technology might deliver versus something that's AI based. So you could think of a vanilla technology as a kind of a clunky, solid iron suit of armor. Okay. So something that knights may have worn 600 years ago when they were jousting, something that is heavy, it's difficult to manipulate and change, it has gaps and weaknesses, and overall it will defend you against some things, but not against others. So that was the analogy that they came up with, and you just wait for the analogy for the modern system. So that works because it's designed for specific types of name variations, and it will keep static lists of those. It will search through lists of names by systematically looking at each name part and following a tree and seeing if it can reach the end of a tree and give you a match. So the longer a name, the slower it is. The accuracy is all down to how well a human can write a rule, and those rules then become complex and difficult to manage over time, especially if they pass through multiple hands. So vanilla technology can be clunky and it can seem old-fashioned. Now the AI-based technology is like a modern Kevlar kind of battle armor that's flexible and light and dynamic and covers all of the weak places with just as much ability as the more solid parts. So that's like AI-based technology, right? We're trying to cover all the bases. We're trying to be dynamic in our name comparisons and not rely on static data. It's adaptive, and it just uses the newest in technology to be able to do that. The market now is very much ready for AI, right? So the algorithms are matured, and the use cases and consumers have matured as well. So we want to be adaptive and use machine learning where we can, use AI where we can. So, and in the long term, having not to be able to have to manage a huge number of rules, you're going to get something that can be tweaked over time without the great overhead of what's gone before. So you get this kind of transparent set of parameter changes and configuration settings. So I'll give you the real demo, but that was that's the overview with the analogy to different types of armor. Now, after all, these things are there for defending you. Now, if you haven't added a question and you're interested, please drop it in the Q&A for after. I'll be intrigued to see what everybody wants to ask. But I'm going to now talk a little bit about why the Rosette name indexer, so our name matching and name screening capability, how that works, and yeah, try and align that with some of the things that I talked about for the AI-based screening in the previous slide. So I'm not going to say it's a simplistic system, but I'm going to be able to break it down at least into these two different passes that occur when the algorithm is applied. On the left-hand side, we have the query, the question, the name that's come in that we need to check against a list. This is one of those common examples. It could be check the name against the list of people due to check in at a hotel, or it could be check the name of the captain of the ship as he crosses the border to see if he's on any watch lists. So it's a name that comes in and it's to be checked against a watch list. We have customers that have watch lists that range from hundreds to hundreds of millions of names. And when you do that, you need to be able to make sure that you at least try to reduce the problem space before you apply some of the more complex parts of the algorithm using AI. So the first pass will draw up a short list from the watch list or the customer list, and it will put forward that short list as a set of match candidates. Now the matching at this point can be quite tenuous. It could just be that the names that go through as candidates are just matching based on initials, or it could be that there is some part of the name that's a crossover. So these don't have to be perfect matches at this stage. As we go through though, that list is passed on to the second pass, the AI scoring. There we go, they've arrived. And here we can look at some of the more complex phenomena that our AI-based algorithms can actually use. We can do a statistical fuzzy match based on the spelling of a name, so compare John with John, or we can do a statistical fuzzy match that uses phonetics, like in the second part there, Amy spelled completely differently from the other Amy. There we go. On the third one down, we look at an idea of removing parts of the name. This idea is token deletion. So does George Walker Bush match George Bush, where that might well be a W, it might be the name Walker, it might be completely missing. But also, does George Walker Bush match George H.W. Bush? Well, there's going to be a little bit more uncertainty there. So I think my webcam's gone a little bit out of focus. Maybe I can make it wake up a little bit. We also cover other phenomena. So we've got the idea of a gender conflict. Two names might sound the same, but might generally be associated with different genders. We cover things like nicknames, and alongside nicknames, it could be synonyms, cognates, or different names that come from different cultures that are the same name but are written differently. Something like John, Jan, Ian, Sean, all might be cognate names, and we want to be able to cover those off as being related to each other. So those are our overrides. So anytime that we have these, we also want to be able to consider them in combination and look at where some parts might actually contribute more to the score and others might take away from the score. So that's the little balance scale on the bottom right there. So we have a positive where a nickname matches, a positive where a phonetic matches, but if one of the parts is missing, we want to reduce the score a little bit. And there we can see, that might give a score like a 0.8. So these lists of candidates, they all come through and they all get scored in this way. And then we want to be able to rank them as which is the best one. So each of them will have a different set of phenomena that are applying, and that will contribute to an overall weighted score. And then we can rank the names that come back and give you the best possible match at the top of the list. Now, rather than continuing to talk about it, I'm going to give you a little demo. And I've got a new demo name that I'm going to be working with today. Oops, there it goes. So this is my demo interface where I can compare a vanilla search. So I've actually got a completely unmodified Elasticsearch index just with names in. So nothing special about it. And then I've got one where I've enabled the Rosette name indexer alongside it. So using all of the AI that we have. The name that I'm going to search is this one, and I'm probably going to spell it. Sorry, not spell it, say it badly. This is Francisco Javier Arellano Felix, or Arellano Felix. I cannot pronounce that very well. And when I write this name almost exactly perfectly, I find that on the Elasticsearch side, vanilla search can handle a name that has 0 or next to 0 variations in it. With Rosette, you can immediately see that we get some benefit though, because we can draw a line and say, well, this is the cutoff line. I don't want to see any names below a 70% match. There is only one name that comes up. There's only one true positive result. We give it a very high score. This is a good match for the search name. If I then add a few variations to this, so let me put that in. You'll spot, if you're eagle-eyed, that I've now spelt Javier with an H, because as an English speaker, maybe I might do that. I might not realize that I can spell that with a J. I've also added a little bit of a phonetic nuance by replacing my F with a PH. I don't know if anyone would ever do that, but just so you can see. Also, the name that I did have, the Arellano, is as missing some of the parts. So what I see when I add this set of variations is that once again, Rosette is able to match it effectively. So Rosette layered on top of Elasticsearch now gives me a score of 84%, where the threshold was 70%. So it's still one true good match. If I look on the left, is the name that I want to search actually in the list? Actually, it is, yeah, it is, but now Elasticsearch has ranked that very low. Now, why is it important? Well, but this name is actually the name of an individual who was part of a Mexican drug cartel. He's actually a real bad guy, and I'm looking on a bad guy list in order to try and screen him. Sometimes if the name doesn't come out on top, it's entirely possible that somebody will dismiss this and say, okay, there's no risk associated. Whereas in the Rosette case, we can identify that name and we find that there is actually a real good strong match. And yes, I should flag that in my screening process. But what happens when the name gets changed a little bit more? So now instead of writing Francisco out full, I write Frankie. I've spelt the last name incorrectly. I've spelt both of the middle names incorrectly. And in this case, vanilla search fails completely to find any match for the name that I've given. This is a worrying situation where you would assume that, okay, I've screened the name, there is no result, that person can be a customer, when actually there is still a risk associated with it. It's something that a smart algorithm will be able to align the sets of names and match them here. Now, I can go on all day doing this, and I'm sure people have maybe even seen me do that. But let me show you just a couple more variations and we'll go a little bit deeper. So I can join names together, I can spell them incorrectly. I can change the name from Francisco to Paco, which is a known synonym and nickname for Francisco, and Rosette will find it. I could even go all the way to deleting most of this, and I can just write it as Paco Felix. So there is no name in common with the actual name that I was looking for. There is a nickname and a misspelling of the surname and then 2 missing parts. And even at that point, Rosette matches the 2 names as it should. So there we go. That is a direct comparison between Elasticsearch, no bells and whistles, no changes, plain vanilla Elasticsearch versus Elasticsearch that's been empowered with the Rosette plugin to enable the 2-pass name screening that I described earlier in the webinar. Okay, I could jump back to my slides, but I know where I'm going to go next. What I'm going to do next is just go a little bit deeper and talk about the customizability and explainability that is built into this name screening algorithm. I'm going to use the Rosette Match Studio. This is a tool that we use with customers for demos. It's a tool that we use to show some of the customizability features that are in there. I can actually go and say maybe with that name again. So I've got the same data in here. I can jump in with Paco Felix, and once again I have one top result there above that 70% line. But now in this tool, I can actually look at an explanation as to why these names are considered matches. So I alluded to it, but here we can see that Francisco matches Paco, and that is an override. So it's a synonym, it's a nickname. If I hover over it, the match was determined by an override file. So there is what we would consider not a black box. You know, there is a user configurable set of synonyms that exist behind this. And Paco, even though you may not know that it's a nickname, Rosette does. Here we can see that Felix matches this variant of Felix as an HMM match. This is using our fuzzy statistical model, and it can see the differences in spelling and the variations in phonetics and give me a match score across these two. And then we have the middle names, and they're considered to be a deletion. So a deleted token in Rosette's default configuration doesn't just give you a 0 score for that part. It actually is based on the statistics that we've seen across names and name matches and the training data that we've provided. A deletion will give you at least some contribution to an overall match. If you care less about deletions, actually that might be something that you could tune. Maybe I'll show you that in a moment. Now, I'm just going to add in another part of the name here just so I can show off some of the customizability features. But you'll spot that if I add in an A, Rosette is able to align that A with the Ariano name and give me an initial match. So one token is the initial letter of the other token. And here it contributes, you know, not a perfect score, but we get half confidence that A matches this name in the default config. So here I've got a couple of things that maybe I would like to tune. So what I'm going to do is I'm going to open the panel over here, and I'm going to look where my button is, hit the reset button, and here I can see what the default set of scores are. So this is a set of configurable parameters. The Rosette name indexer has a list of several hundred. There are a set that are more common than others, and we're exposing them with this. And some of the more common ones are things like the score that we are contributing based on an initial. And in my case, maybe I want to increase that a little bit. So now if I see an initial, I've got a stronger sense that that is more likely to allude to a name that it starts with. And now if I've changed that and I hit the compare button, now instead of having just over a 70% match, that jumps up to a 76% match. So I can change the scores that Rosette gives out by doing some of this configuration. Maybe you wouldn't want to do this all the time. It might be something that you want to set when you first deploy a system. Alongside the initial score, maybe it's something I would care less about the deletion. So maybe I've got names that are embedded within longer strings, and some of the part of those strings are just noise words. So if I don't care so much about noise words, I want to actually increase the contribution from a deleted token. I can change the deletion score, and that jumps up. And now, if I had set a threshold over 80% as my baseline, by doing that that little bit of parameter tuning on those two parameters, I've pushed the score up from 70% to 80% or 81% in this example. And that can be deployed long-term for use with your list-based matching rather than just this side-by-side pairwise matching. Now, that's pretty much the end of the demo that I wanted to give you. That was the customizing name matching section. I know I've been talking at you for about 25 minutes, but now I've got to the point where I've shown the comparison between vanilla search and vanilla search plus RNI, and I showed you some of the customization that can be done to Rosette name indexer in terms of changing the output of the scoring. So I'm happy now to look at the questions that have been given during the webinar, and maybe I'll just take a look at that now and answer any questions. If you have any questions that you want to add, feel free to type them into the little questions box, that you've got. I'll give you another reminder again that when the webinar finishes, please jump in and fill in the survey as well. Our marketing team will appreciate that. Oh, I think I've got a question. I've just got to expand the window a little bit. Oh, here we go. Oh my goodness, we've got quite a few. Okay, so I've got a question about nicknames. With nicknames, do you only do shortening, or do you have mechanisms for other nicknames like Chalky, Slim, etc.? Yeah, so a nickname can be any name, so it doesn't have to be just like a truncation. Actually, we consider truncation separately from nicknames. It could be Peggy versus Margaret, for example. Those names don't sound anything like each other. Or Paco versus Francisco. Somebody suggested me a search for Frankie Felix. I think that would probably work. Maybe we'll save that one for another time. There's a question: which search engines can Rosette work with? Is it just Elastic? It's not just Elastic. The reason we demo with Elastic is that we see it quite often, but actually the name indexer has been designed as both an SDK, so that actually you can roll your own with any of the search engines out there using our metadata. And also we have pre-built plugins that work with Elasticsearch, but also with Solr, and also we have several example Lucene integrations as well. But yeah, the SDK gives us a large amount of flexibility. And yeah, if you had a search engine in mind that wasn't one of those, feel free to send an inquiry over to us, and we can talk to you about it. Another question: do we offer a standard override file? So we ship with an override file, but it's one that we have curated ourselves. So I know that there are a lot of name search engines out there, and it's their proprietary information, is their set of overrides, their set of name variants that they consider to be matched in advance. Our names override file has about 7,000 entries, and with the product itself, it's an open text file that anybody can read, update, or replace with their own set. So yeah, we think that it's reasonable for the job, and actually a lot of our other matching phenomena cover things that aren't covered by the overrides file. But yeah, it's not a black box. But yeah, it hasn't been sourced from anywhere else. It's curated by us. Let me have a look. I've got actually quite a long list here. I've got a question. Curious on how scalable Rosette is for large volume processing. That's a really good question. I can give you some examples. So recently, I've been involved with customers based in the UK. I've got UK Home Office as a customer, and you can go onto their procurement website, and you can look at the scale that we're working with them on, and it's based on being able to process all of the border crossings every single day for the United Kingdom. So that's a scale that you might consider. We also work with customers that do financial screening, and we work for customers that do that on behalf of others. So we have one customer that has 9,000 end customers, and they're doing over 250 million name screens every night for batch processing, and they have that deployed on a AWS cluster using Elasticsearch for its clustering, and then using Rosette on top of that for the precise name searching. So yes, it scales up and up. So it says, I've got a question: is it possible to connect this logic to enterprise systems such as SAP? So I'd say yes, absolutely. Our software is built with integration in mind. We build plugins, we build APIs, and we build SDKs, and we have many integration points that work with other large enterprise software. So that's a big yes. I have a question on language. Will this work with Arabic or Thai to Latin watch lists? So I didn't have time to do much on the cross-lingual, multilingual side for matching. but I'd say that both Arabic and Thai are supported languages by the Rosette name indexer. And also we do cross-language matching, which means you can have a name in Arabic versus a name in Latin, and Rosette would give you a match score based on how similar they were. Same for Thai. So yes, it would work. And even a multilingual watch list. You could have a watch list that has many different languages on it. It could be Arabic, Chinese, Thai, Korean, Russian, Vietnamese, Urdu. You know, you could have multiple different languages. On our website, the tech specs for what languages are supported are listed out. But it's something that we are growing every year. I think recently we added Hebrew, for example. Okay, trying to click through what I haven't got. Right, let me see. Trying to tick off the ones that I've answered. Gil says that I have to learn how to pronounce words in Spanish. Absolutely, I do. That's not a question though, Gil. Okay. With the Studio, you can dynamically change the scoring parameters in real time for the plugin. Is that installed separately from Elasticsearch? Okay, so our Match Studio is designed to show off the features of Rosette, and there is a dynamic parameter feature that exists in the plugin. Now, it's not for production use because it slows down the matching and the engine considerably when you switch it on, but it's very good for showing the instant impact of things. So it can be used by our customers if they wanted to take a copy of Match Studio, do some parameter tuning there, then take the parameters that they've configured into a static file and then put them in their deployment. We would never recommend that you keep the dynamic parameter function switched on in production just because it slows it down so much. All right. Okay, so Ed did ask if you talked to the more transparency. I think that was from earlier in the presentation. I was talking about, you know, an AI-based system wants to be transparent, and that's really about the explainability of how it gives you a result. And it's something that we've worked on almost from an engineering perspective. So our matching grid that you saw in the demo was something that's used by engineers to understand why two names matched and which parameters were invoked and which weightings were applied. We're getting better at turning that into something that's more explainable from a business point of view as well. We know that customers are under regulatory pressure, and with that regulatory pressure, they need to be able to explain in plain English why two things happened. You know, so why two names matched, why a decision was made. So that's something we're constantly working towards, and sometimes it can be difficult with AI-based algorithms. So that's why we try and expose as many of the weightings as possible and show where those can be configured as well. And one more, you say the system is not slower for long names. That's absolutely true. Yeah, we have a pretty much average response time, but the thing that does affect it is the size of the watch list. So we have metrics where we can measure when you change the size of a watch list, how long it takes to come back. And then at that point, if something is taking too long, that's when you might consider scaling up, you know, adding more CPU cores, or scaling out, adding more nodes to speed up the matching. Right, I think unless anyone has any more questions, then that is the end of the webinar for today. I'd like to thank everybody for their attendance. I think the attendance has been fantastic. It looks like a great number. I'm hoping that you'll all come back for the next webinar next month. You will all receive an email inviting you to come to that. I hope you enjoyed the demo, and please, as I've reminded you before, please fill in the feedback form survey after this has finished. You'll all get a recording of this in your inbox. Feel free to send it to your friends, and maybe I'll see you at another one of these. All right, thanks everybody. Goodbye from me. Thanks.